How's it going, PreCalc kids? This is the last video of Chapter 3, 3.6, Mathematics of Finance. Finance. Okay, I gotta wait for my movie, connect, and now we're good. Okay. If a principal P is invested at an annual interest rate of R calculated at the end of each year, the estimate after n years is A equals P times 1 plus R times N. Okay, here's the noteworthy Mr. T version, guys. Your annual total, this is your total cash, as Randy Moss once said, straight cash only, equals your principal times 1 plus your rate to the n years, right? Principal, that's going to be our initial value. Our rate is our rate. Our n is number of years. Now you guys may have seen this before, but we are going to take it to a whole new level. This is where it gets interesting, guys. This is where interest compounded k times per year. That means this compound more than just per year. Like many banks do it monthly. Okay. The more it's compounded, the more interest you get, and you're getting interest on your interest, hence more money. That's a good thing. Okay. So here's the noteworthy part, and I'll rewrite it. If you want to read the rest of it, go for it. This is your total still. Straight cash is equal to your principal, your starting, times 1 plus your rate divided by k, all to the k times t. Now let's define some of these. A, P, and R, and T. T is going to be time. But k is number of times compounded per year. Okay, so like if it's monthly, then it'd be P times 1 plus where your rate is over 12, all to the 12t. Okay. If it's daily, you put 360 there. Okay? That's all there is to it. It's time in years, by the way. Handwriting's getting worse. Let's take a look. Suppose Paul, our good buddy, takes $400, puts in an 8% annual interest compounded monthly. What's his value in 5 years? So Paul, put $400 in. So we go $400 times 1 plus, what's our rate? 8%, 0.08, divided by, well, it's monthly, right? Divide by 12. Put our 12 up here, times our t, which is 5. Okay, so we get 400 times whatever this mess is. I'm actually just going to plug in my calculator, to the 60th. Okay, so I grab my handy dandy calculator, which I have one right next to me, and I plug that in. And I get his investment will be worth $595.94. It's not so bad. It's free money. Okay. Here we go. Noteworthy equation, definitely. Your total is equal to your principal times your e to the RT when interest is compounded continuously. That means every second of every day you're getting interest on your money. You're gaining that interest. You're getting interest on your interest. Alright, so we're going to change this. Same problem, but it's going to be continuous interest, okay? So So it's going to be compounded. Sorry guys, we had a diaper blowout situation, so everything's under control though. It's going to be compounded continuously. Okay. So here's how we set it up now. We use our PERT formula. Makes our hair nice and shiny and fantastic. So we go 400, our principal, times our good old E. Our rate is 0.08 to the T, which is 5 years. Okay? So we plug that into our handy dandy calculators. Okay? And when we plug it in, we get, oh, let's see here, we get Paul is worth $596.73. Now back in the 90s, a lot of banks said, we compound continuously. And our banks are like, well, we only do it monthly. But you can see here the difference is about $1. Okay, even less, 80 cents. So it's not that big of a deal, guys. Okay. This is a big problem. This is a huge problem. Judy has 500 bucks. Invest at 9% annual interest compound monthly. How long will it take to grow to 3 grand? So, here's the setup. You have your 500 times your 1 plus your rate over how many times is it compounded a year? 12 monthly to the 12 times T. We don't know how many years, right? So we want to know how long it's going to take for that to be equal to $3,000. Okay. Now we're solving for T, so our first step is going to be divide by 500. So I divide this guy over here by a 500. Okay? You know, I'm actually going to calculate what this decimal is because it'll make our life easier. Okay. So we get 1.0075. Again, I just divide that out and add it to it. To the 12T. Equals, that's 6, right? Now, how do I get rid of this 12T at the top? How do I do it? I don't know how to do it. I need to get rid of it though. So here's what you do. You natural log both sides. Again, I like using natural log. Because when you do that, this 12T, you move in front. So you get 12T times the natural log. And guys, plug this in your calculator, it's just a decimal. Okay, so then what you do is you divide both sides by your natural log, 1.0075. You divide by your natural log of 1.0075. Okay, and that's a decimal. In fact, I'm going to plug my calculator right now. Natural log of 6 divided by natural log of 1.0075. When you divide those out, you get 12T equals 239.7960266. And from here, it's good old-fashioned divide both sides by 12. And you get the time it'll take is about 19.98 years. Okay? All there is to it. Easy. Okay. The second way to do it, or that's it, guys. Now, let's do the same problem as above, but we're going to use it compound continuously. So they're still starting with 500 bucks. Now we use E to our rate was 9% T. And we're saying that equal to 3,000 years. Okay. Again, our first step is going to be divide by 500. Divide by 500. So we get e to the 0.09t equals 6. Now, this one's actually going to be a little bit easier because what happens when we natural log both sides? These just cancel, right? So you have a 0.09t equals natural log of 6. Divide both sides by 0.09 and t equals natural log of 6. Divide by 0.09 and we get approximately 19.9 years. So pretty close, right? In fact, you're only going to be saving a few days if you invest continuously as opposed to monthly. Okay? I actually really like these type problems, but you guys all think I'm insane already, so whoa.